few companies that actually still manufacture PA product in Australia, so they've got a nice manufacturing facility. They've also got a sound chamber up there in Pascoe Vale.
Pascoe Vale, this is.
Which is all very impressive. They're always very happy to lend a hand. 100 volt line, they do hearing loops, a whole bunch of different products. So yeah, some expertise from some guys that actually make stuff.
Thank you for that introduction, and hopefully I've got something for you that you can use. What we're going to go over, essentially it's PA installations, obviously. We're going to start with 100 volt line. I'm going to possibly, at the risk of boring you a little, I'm going to go into a little bit of tech talk with it, but if you can stay with me, it actually all relates, and at the end product, hopefully you'll be able to walk out of here with some useful tools that you can apply next time you've either got to either design one or specify one or install one, or heavens above, go and try and fix someone else's that after they've done the ring around and they say, oh, it's making funny noises, mate, you know. So you've got to turn up there at the Doveton RSL and diagnose and fix their system with no budget, because they spent it all with someone else who stuffed it all up. So anyway, audio installations made easy. They don't have to be too hard. In one respect, unlike video, which has been a very changing landscape very quickly over the last however many years, the audio, dare I say, is still pretty much rooted in last century. But obviously we've got the 100 volt line type systems, and then we've got what we could call the low impedance system. You go into a nightclub or there's a band blasting away, that'll be a low impedance system. You go into a shopping centre or Tullamarine Airport or Bunnings or something, well, there's your 100 volt line. Now, there is an area of crossover. Normally it was there was one or the other. It is possible to do a bit of mix and match, and in fact it is also possible. There's a part of the market that's kind of emerging that you might be interested to know something about in the low impedance market, that is something that's, anyway, we'll get to it. There's another approach where you can use low impedance to do very high performance installations for not a whole lot of money. Obviously, just a quick idea, who here does 100 volt line installations or has done? Okay. Who does PA installation, you know, the big noisy racket PA? Anybody do those? Okay, how about the combination? Did anyone have to go in and fix one? Okay, so obviously with 100 volt line, there's a number of advantages, and they've been around for a long time. You can whack extra speakers on if someone wants another speaker put on a system. Theoretically, yes, is the answer to that. You go and put another one on. You can run long cable runs. Once again, in theory, still has to be done properly. You can run 1,000 feet of cable and still have something happen at the other end, done correctly. And you can, in the case of some systems where people used to do a series system, one speaker cooks and you lose the whole system, whereas of course with the 100 volt line, it doesn't matter if one stops, because it's all on a chain that can't be easily interrupted, unless of course someone puts a tech screw through the ceiling installing in the air conditioning, in which case that can put you off the air quite quickly. The main difference, of course, is this thing. That's the transformer. There's a transformer on the amplifier and another one on the loudspeaker. There are some limitations. You'll see on that transformer it doesn't actually give you wattages, but if it did, the maximum wattage is often optimistic. If that was, let's say, that was say a 10 watt transformer, and you hook it up to 10 watts, and you expect a bit of VUMO out of it, it's probably going to be a bit gravelly and not great. So realistically, what happens is you push too much into it, the transformer saturates, and then you don't get any more out, and if anything, the thing will overload and distort. So that's your limit. with the transformers, where in a case of a low impedance system you can actually push them a lot harder. The principle behind this is the same way power is distributed. When people say, what is a 100 volt line? Well, essentially what you have is a constant voltage and changing current. Now, in a power station, you have the generators, which are quite often very high current producing generators, very high amperage. They then go through a step-up transformer, or actually a series of them, which turns it into high voltage. Along transmission lines, the high voltages losses are lower. If you have high current, in the old days when they started with electrical power, the first electrical power was actually DC. And of course, practically every block in a city needed its own little power station, because the losses would be so high down a DC line that if you're at the other end of the line, you're only getting half the power of the guy who's the first in the line. So that was a problem. So high voltage alternating current became the standard, so they could run it longer distances across thinner wire. And of course, at the other end near your house, at the end of the voltage, the high transmission lines, you've got a substation. We've all driven past those. That steps it down to a lower voltage, but it's still pretty high. And then as you get closer to your house, there's a pole with a transformer on it, and that steps it down to your 240 volts. So same thing, the longer the distance, the higher the voltage. As you get closer to your house, they can start dropping the voltage, because let's face it, you don't really want 100,000 watts at your power point. Same principle with a 100 volt line amplifier. You've got your amplifier. In the 100 volt line amp, there's a big transformer that turns it from low voltage and high current to high voltage and lower current. And then of course at your loudspeaker you have the transformer that reverses the process. And as I said, it allows you to have longer cables with lower losses. It doesn't mean no losses, and it doesn't mean you can necessarily use microscopically thin cable, but it does definitely have the benefits of long distance. Now, you'll see on the transformers, you'll have a sequence of wattage tappings, 5, 10, 15, 20, it could be up to 50 depending on some of them. Obviously bigger wattages need larger transformers. A cheap ceiling speaker that's only got to be above your head obviously needs a lot less wattage than something that's sitting at the top of an atrium. And essentially, as most of you would probably be aware, depending on the tapping will determine how much volume you're going to get out of the speaker. The wattage tapping determines essentially how loud it's, what the draw from that amplifier for that particular speaker is going to be. Now, you could turn around and you could say, okay, how many watts should it be? If you've got to go and install some ceiling speakers, you've got areas of differing height, but you're installing the same speaker. You've also got a limited amount of power, so the question is, what wattages do you actually use? There's nothing more annoying than when they've taken the scissors lift away and put the chairs in, when you turn the sound system on and you realise that some of those ceiling speakers are set too low. What are you going to do? You have to climb up there and reset them. That's a bit of a pain. If you could figure out how to not do that, you'd be definitely helping yourself. Now, I'm going to get a little bit technical here. We're going to talk about the dB scale for a sec. Now, anybody seen a dB scale before? Yep, we've all seen it. I mean, they normally start at the bottom with the threshold of hearing, the quiet room, the bedroom of two people who've been married for 60 years, followed by, it gets progressively louder to jackhammer, and I think they finally end at, I think it's something like Clive Palmer Passing Wind or something around the back end of a jet. So consequently, it's not a scale that is something that is to go twice as loud. It's not twice as powerful, and that's something that's quite important. The dB scale is not what we call a linear scale. It's not based by just a line going from here to here. It's actually, as you progress up a dB scale, it's a multiplier. So what we're doing is each step along the scale is a multiple of the previous one. Now, here's an example of a linear scale, 1 to 10. Each of the divisions are the same in terms of the result. The dB scale is a logarithmic scale. So as you can see, as you go further up, there's more of it. Now, the ear is a really poor determiner of how loud something actually is. You can see we've got two little scales there. The way it works is if you have something that's twice the power, you don't hear it as twice as loud. And this is where we start to get into the thing of the logarithmic scale. Small increases of sound that you hear that seem like, oh yeah, that's a bit louder than that, that's going to require 4 times the power. Stay with me here, because this is where we get to the tappings on your 100-volt line speakers. And the more power you use, the less noticeable it is. Now, okay, the difference between 1.5 watts and 3 watts, you go, oh, I think that got a bit louder. 100 watts to 200 watts, oh, I think that got a bit louder. You'd actually have to go from to something like 400 watts from 100 before you say, oh yeah, that got louder. And it's not all that much. Now, what I'm going to do is I'm going to demo exactly how this works. What we have here is a pink noise test, and each one of these is dropping by 3 dB. And by 3 dB, I mean we're doubling, we're halving the power with each change. So you can see, you can notice that. Okay, we'll move on to the next one. Come on. Now this. Now that hardly sounded like any change at all. Now what that was dropping by 1/3 of a dB per segment. So you can see that 1 dB, you're not going to hear it. No one's going to hear a difference. And how that translates into a ceiling speaker is no one's going to hear the difference between 5 watts and 7.5. So now we get into the main considerations of actually doing a ceiling speaker installation. There's a few questions you're going to have to ask yourself. Is it a high ceiling? Is it a low ceiling? Is it a venue that has both? What's the background noise? Now, bearing in mind that architects, I call them ego techs actually, there is actually a decorative effect. Sorry if there's any architects watching, but look, that's how it is. They're only there to hold their designer glasses. Now, having insulted architects, I'm going to back this up, is that they hear with their eyes. They don't pay any attention. When do you ever see a sound system drawn into an architectural drawing? It might be done by a consultant, perhaps. When the architect brings in their nice render of here's your venue, with all of the quite attractive aesthetic with it. Has anyone ever drawn a loudspeaker? No, of course they haven't. And then you walk along with your speaker system and go clang, and they're horrified that this is going to be put in their space, you see. So realistically, there's a lot of design considerations you have to do when you're installing a sound system. Now, it's not so bad with a 100-volt line because it's next to the air conditioning duct or something, so it's just another piece of utility that's being installed. But there's a lot of stuff that you have to consider unless you want to have to keep going back there fixing things. Now, your average architect design building in the current kind of postmodern contemporary vibe is hard surfaces, strong lighting, lots of reflection, things like this, polished concrete floor, windows everywhere. You're not going to see a curtain for days. There's going to be nothing that's going to soak up sound. And if you look at the way sound reflects off hard surfaces, it is not uniform. There are certain frequencies, depending on the surface, that reflect more than others. And in the current vibe, if you've ever been in a modern restaurant, there's no point in putting a sound system in it because you'd never hear it. The background noise of people talking and all the clanging, and it's right in the vocal range. It makes, if you're a bit deaf like me, it's like, what? Because it washes over all the consonant sound in the speech range. So as much as you can hear someone talking and they're loud enough, that constant reflection of mid-range can destroy the intelligibility of the sound system. So these days, when you're putting in a ceiling speaker system, if a person is getting more reflected sound than what they're getting from the ceiling speaker, they're going to miss it. You can even get to a point where, say, a notorious one, Qantas, when you're going in that first bunch of, when you go in there and you turn right and then there's a whole stack of airport gates. Whenever I hear a page, it's, you can't understand, unless you're standing right under a ceiling speaker, you can't understand. You've put in the wrong speakers, they're in the wrong place, and there's not enough of them. So they're all factors that have to be considered. Hate reading my own slide, but is it program music? Is it going to be an announcement? And is that announcement going to get over the background music? Well, probably ducking, so that doesn't matter. But is it going to get over the background noise? Now, we have a look here. The average noise level of a couple of different places. Now, bearing in mind that sound diminishes by what they call the square of the distance, which means if you're twice the distance, you've lost 4 times the energy. So as much as that is in theory, it's not completely right in practice. But if we have a look here, you're in a retail outlet, the average noise level at 70 dB. Remember, you've got to be 6 dB over the background noise to be heard, so that's 76 dB. Sound output. So whatever sounds good when the room is empty, that sounds okay and seems loud enough, will not be loud enough when the place is full of people. So whatever tapping worked, if you do a test, you're going to have to at least double it and factor that in when you're doing your install. Same thing goes with distance. As I said, they talk about sound diminishing by the square of the distance is the theory that they apply, but it's actually not quite true. It's not actually quite that bad. But what makes up for it in most places is your average ceiling speaker is not terribly articulate, and unless you're pretty much standing under it, you won't. You can lose it. So this gets back to your ceiling speaker performance. Is what's the width of coverage of the high frequency response of the ceiling speaker? Is it narrow? Is it wide? If you put a wide speaker in a high ceiling, it's going to bounce everywhere and lose intelligibility. If you put a narrow speaker in a low roof, unless you're standing under it, you're not going to hear it. So these are all factors to consider. That you are going to have, as you go higher in the air, you're going to have much greater losses. So when you're putting ceiling speakers into rooms with varying heights, you actually can't set them all the same. The ones that are going to go in the high ceiling have to be louder than the low ceiling ones. The high ceiling ones, ideally, you need a narrower dispersion speaker that will project, and in the low ceiling areas, you want a wider. Now, the thing in a low ceiling, where it doesn't have to be as loud, you can also use a ceiling speaker. Low-powered ceiling speakers are normally more efficient than high-powered ceiling speakers. The cones are lighter, there's moving less mass. And in most cases, the low-powered ceiling speakers, most of them have a wider dispersion. So if you want to put some more margin back in your job, if you sit there and you're going to be doing a bigger one where you might have to put 30 or 40 ceiling speakers in, if they're not all in areas of the same height, you can actually get away with a cheaper ceiling speaker in the low ceiling parts of the job. Bear that in mind. You're just not going to be able to use them when you get to your high ceiling parts. And you can see that on this little chart there, I mean, some of these are in feet, some are in inches, but you can see that if you've got a seated listener in a high ceiling, you are going to need a lot more juice out of your ceiling speakers. Now we get to the principles of actually installing them. We've got that great party line capability where you can just hook them all up in parallel. Remember we were talking about that you have to double the input power to hear a difference. Going from 5 watts to 7 watts is going to make very little difference to the output of the system. So what you can do, I mean, technically, the way to calculate this is if you've got to work out how much amplifier you need for how many speakers. You've got a 100 watt amp. Theoretically, people say I've got 10 watt speakers, that's 10 speakers. Actually, that's not true. That's what in reality, you need to build in headroom, because when you see the specs on these, what they do to make the speaker seem louder, a lot of speaker manufacturers use a transformer that is actually pulling a bit more juice, which then gives, when they say, oh, their speaker is X dB at whatever watts in, what they're not telling you is that the transformer, they've done the measurement at the loudspeaker, they haven't done it at the transformer. So there's a bit of Mickey Mouse that goes on with some of the specs here. So for a number of reasons which I'll get to, you always need to overpower the system. Another thing, of course, you can use if you need a lot of coverage is horns. They're not quite so popular these days. They can throw a long distance. They sound a lot like this. You know, you can't use them for music, but you can get a lot of output out of a horn system. But basically, they're only good for voice. Now, getting to this point of how many speakers can you put on an amplifier, if you're doing 100 volt line installations and you want to make the job a lot easier, you need one of these. It's an impedance meter. Radio parts, as it turns out, sell them. There's a picture of one. What these do, when you've put your system in, if you really want to know how much amplifier power you're going to draw, let's say someone rings you and they say, oh, I've got a speaker system and it's distorting, or they want to add speakers or whatever. You get there and with one of these you pull the line out of the back of the amp, you put it on the impedance meter, you switch it on and you measure the impedance. Now on the back of most of these impedance meters, they have a little chart, and what the chart will tell you how impedance relates to power, so that at 300 ohms it might be pulling, let's say, 65 watts or 100 watts or something. And as you go lower impedance, you're pulling more and more power. The first thing that's going to make your system distort is if you've got too many loudspeakers, or if the impedance is too low and the amplifier is trying to feed too much. It's allowing the amp to pass theoretically beyond what it can do. Now, if that was a digital type amplifier, you'll just blow it up, or it'll thermal and shut down. In the case of an older style amp that's got the big heavy tranny in it, it'll get hot, it'll keep going, but it'll distort. So the number one thing you need to buy is an impedance meter. You can buy really expensive ones like this NTI one, or you can buy, there's the good old Toa one, which is also reasonably pricey. The Redback one is a ripper, actually. It's probably one of the cheaper ones, but gives you a digital readout. It's got a chart on it. That is the lie detector in a sound system. You plug that thing in, it pumps a tone through and it gives you the impedance. Now, impedance is not resistance. Whatever you see on a resistance meter is not going to help you. You really need the impedance meter. And then you look at the chart and you go, okay, that's what I've got to work with. Now you need ideally another 20%. So you need to look at the back of it, you go, okay, that's telling me that I've got X ohms and I'm going to be pulling 200 watts. I've got 150 watt amplifier. Well, in actual fact, you're going to need a 250 watt amplifier to make that stable for yourself. Now, let's say you do that, you look at your impedance meter and you go, okay, I've got too many loudspeakers, I can't be bothered climbing up there and changing all the settings, half of them in places I can't get to. How do I lower the load? Well, it's very simple. Most of these amplifiers have a terminal strip on the back, and they'll have things like 70 volt, 100 volt, some might have 50, some even may have lower. You drop it to the 70 volt line setting. That's a little trick. Even if you don't have the impedance meter, if your system's distorting, you want to find out if your amplifier is trying to your load is drawing too much power. Stick it on the 70 volt line setting. Straight away you've halved the load that the amplifier is seeing. Now, remember what I said about 3 dB and halving the load. You're not going to hear the difference. So you can drop a system from 70 volts to 100 volts, 100 to 70. You've halved the load on the amplifier, and nobody is going to hear the difference except the system no longer distorts and will now have more clarity. Then you just simply write them out an invoice for $600 and off you go, you see. So now what I've done here, I've put a little list together of basically, you know, a quantity of little tricks. These are the basic rules of getting good results out of a 100 volt line sound system. The first thing is when you wire them up, you know, you've got the black wire and the one with a stripe on it, or you might have a red one or whatever. You've got someone pulling all the wires through, maybe if you're lucky. When you hook up the speakers, you'll see the black common wire. Make sure you wire them all the same. Now, if you get them back to front, or you've got the apprentice doing it because you don't like the spiders in the roof or something, what you do is you make sure they wire them the right way around, because if those speakers are closer together, it's not an electronic problem, it's actually an acoustic problem. Because if they're in reverse polarity or reverse phase, what's going to happen is at a certain set of frequencies and distances, you're going to lose the bass response. And you'll actually get a lot of loss out of the system. And of course, when people find something's not loud enough, the first thing to do is turn it up. Then you're going to start running out of power. So it's very important to maintain consistency of polarity through your connections. The next thing gets back to that headroom point. As I said earlier, never install a system so you're using more than 80% of the available amplifier power. A distorting amplifier will kill a loudspeaker faster than too much power. If the system is distorting, get out your impedance meter, test it for total impedance, and then calculate that against your wattage. It's just not hard to do, especially if you're using 10 watt tappings. And if you don't have the impedance meter, or you want to do the real quickie way, whack it on the 70 volt setting and see if the distortion stops. As I said, 20 to 30% is really, power these days is cheap. Now, the other thing you'll notice is that these days there's a lot more people using or selling digital amplifiers, the little one rack space amp. You go into some venues now and you walk in with your clunky old one and there's only a limited amount of rack space. People, the modern venues, especially when you've got a heavily zoned system, they like these one rack space multi-channel amps. The only thing with those is that they don't have the headroom, and if you run one into a dead short, you've got a fair chance of completely frying it. And don't even think of trying to fix one. A lot of them are really blow and throw. The other thing is too is, we'll get to the cable thing, speaker power. Point number 3, the 5 watt ceiling speaker or the 10 watt tapping. Remember, you've got to go, you've got the difference between your 10 and 15 watt tapping, no one's probably going to hear. You've almost got to go like to 30 before someone's going to hear the difference. So as much as you can type of zone it, where you can have different levels in different places, you are going to have to really make sure that your system when you do have to turn it up isn't going to overload and distort, that your loudest bits are loud enough and that your quietest bits aren't going to be too loud. The cable management is very important in this kind of installation. I've seen installs where someone's had to do like a large terminal area where they might have to put in 600 ceiling speakers, low powered ceiling speakers, and they go, a cheap way of doing this, they go and get a big amp, like a real brute amp, they put it there and they run this massive party line through the whole place, and then someone lifts a ceiling tile and installs something and accidentally shorts out a wire and the entire system goes down. And then you've got to go and find it, right? That is just a massive headache. So the cable management, if you're going to install 60 speakers, you're better off running multiple feeds, labelling them at the amp, and also labelling them inside the roof. Even if you're using a different coloured cable or different coloured lecky on it or something, make sure that if you have to go back and find a fault, and as I said, someone gets in there after you've done your install and moves something, massive headache. Tidiness in the cable runs and doing multiple runs is really something that can save you a lot of messing around. Now, another thing that people do, another old one that still works, is the good old local transformer where you can... now, I've seen people install a potentiometer. It occasionally still happens. There's all sorts of things that people will put in. The number one thing here is to make sure, once again, if you're going to use a local transformer to turn sections of your PA down, make sure you've got your voltages right, because there's no point in having a zone with 5 watt speakers controlled by a 10 watt transformer. It's not going to happen for you. As I said, manage your circuits in a manageable way. Make sure. The other thing you can do when you're running multiple feeds is, before you hook them up, double check it with your impedance meter. There's just nothing like hooking it all up and then finding that something's bringing down your whole system. So measure your feeds before you actually put them on the amplifier. As I said, there's the trick of the 70 volt line. If you do find that you're using multiple amplifiers and you've got one feed that you've got a bit of a power problem, just put it on the 70 volt line setting. Another great killer of systems, and another good reason for having an impedance meter, is loudspeakers that can be run at 8 ohms or 16 ohms and have transformers in them. It's super easy, if you're putting in a whole lot of speakers, to accidentally, when people are setting them up, especially when you're up a ladder, is to hook it up at 8 ohms. Now, if one of those speakers is running not through the transformer, that can really ruin your whole day, because then you've got to go and try and find it. You'll do all your calculations, you'll say, yeah, this is no problem, this is all going to work. You hook it up and it's distorting, and one speaker is super louder than all the others. Well, there's your problem, and it'll also be distorting as well. So make sure that you do not hook a 100 volt line amplifier up into a low impedance speaker, because if you do that to a digital transformerless output, you run a real risk of frying your amplifier. The other one is speaker cable. Now, with 100 volt line, as we said, you can use skinnier cable, you can run at longer distances. That doesn't mean you use bell wire. You will still have losses over distance. I think I can't remember if I've got the chart in there or not, but you can get a cable chart that will tell you losses on a 100 volt line. It's worth looking at, because don't forget, if you lose 3 dB, you've just lost half your amp power, and the speakers closer will be getting more juice than the ones further away. consequently, the ones further away, you're going to have to run higher tappings. So if it is 400 feet away, that that 5 watt setting, you're going to have to go to the 10 watt setting if you're at the other end of the line. Just bear that in mind, because it just might happen at the other end of the line is actually where they want all the noise. Now, moving on a little bit, low impedance systems. Does anybody have to have you ever anyone done an install in a church, or have to do something where you're not doing 100 volts? Okay. Yeah, well, there's a few differences here. A low impedance system, obviously, they're louder, you've got better audio quality and more power. Now, I don't necessarily mean that they have to be big. Here's a little system in a bar in Melbourne. That's a sub and a little satellite speaker. Modern satellite speakers, that one there, that happens to be one that we do, but there's others around. That little speaker can take 350 watts RMS, and that's a lot of power out of a tiny little speaker. Same thing with the sub. You can push 700 to 800 watts into that sub. Now, remember we were talking about architects designing these funky spaces, and you walk in with your clang, here's your sound system, and they're hating you. Now, the trick now is to run a lot of little high-powered speakers that you can hide, but the rules still apply. You have to use thick cable, none of them can be too far from the amps. The low impedance speaker system generally is not suitable when you've got to run long cable runs. The other thing is with them, as far as your connections go, for most of them, the rule is you've got 2 satellite boxes per channel of the amplifier. If they're single driver subs, it's 2 subs. Most amplifiers really 4 ohms is about the maximum or the lowest impedance they want to work with. Most little speakers are 8 ohm speakers. There's a few that are 16. So you automatically have a limitation. Now, some people will try a series wiring, because 2 8 ohm speakers gives you 16 ohms. Then if you hook up 2 more 8 ohm speakers in parallel, it'll bring you back to a 4 ohm load. It's called a series parallel wiring, and it's really easy to mess it up, and you've only got to get one of those out of phase, and that's, once again, can trash the performance of the system as well. That's the downside of those kind of systems. The other thing is, of course, is your wire gauge. We get back to, they want to put all the amplifiers in the back room where the beer pumps are. The loudspeakers are in 2 flights away, or in the function room or something like that. You are going to have losses. Now, you'll notice that the losses here compared to a high impedance system are huge. You've really got to use thick wire. Now, if you look here, for instance, use like 18 gauge wire compared to 10 gauge wire. The lower the impedance, some systems allow you to hook them up at 2 ohms, look at the losses you get. At 18 gauge, you've lost 3 dB over a relatively short distance. So you've just halved your amplifier power straight away. So bear that in mind. In the world of concert sound, and this is a thing we do a lot of, the amplifiers are virtually stuck to the loudspeakers. They have to run the shortest cable, and those guys are running 4mm cable, and look how close they are. So, very important cable runs. Now, I was talking earlier also about amplifier power. We talked about headroom. If you're running a higher powered system, don't be afraid to use twice the amplifier power of the speaker system. Now, I know that sounds counterintuitive, but what burns a loudspeaker is distortion. Because the loudspeaker the voice coil can't reproduce a square-waved signal. It's got a component of what they refer to as DC. Now, that just goes up in heat. So the more distorted the signal, the hotter the voice coil will get. If you, I don't think I've got a picture of it here, but if you have a voice coil with a lot of power and it's pumping a lot of air, that will actually be blowing air over the voice coil. It helps keep it cool. Once you start introducing DC, the thing will get hot. So don't be afraid to use a fair bit of power. And in fact, a 100 watt amplifier is capable of putting out 200 to 300 watts of distorted signal. So that means that you could have a 200 watt loudspeaker, but it could be getting 300, even 400 watts of distortion. So not only is that 200 watt speaker getting a lot more than 200 watts, it's getting really dirty signals. So bear that in mind. 6 dB peak from a 100 watt amplifier is 400 watts, and that's 400 watts of distortion. So fast way to kill a loudspeaker is distortion. Yet an amplifier that's a 1000 watt amplifier, if you're running it at 500 watts, I've seen 100 watt or 200 watt speakers powered with 1000 watt amplifiers run intelligently. They sound better and they actually last longer. Now, getting back to this low impedance speaker system, here's an example. This is a nightclub in Hong Kong. Another case of the invisible PA. Once again, sound diminishing by the square of the distance. If you're close to a loudspeaker, it's going to be louder than if you're further away. So you can create a big nightclub effect by just running a whole lot of high-powered small speakers and having it so that nobody's very far away from a loudspeaker. So that you have a uniform coverage of sound. Everyone's hearing basically the same thing. Little speakers that don't have to produce bass. You know, you need the big speakers that produce the bass. So it's not that hard to design into a building somewhere to put bass speakers. So that's another trick. You've got your full range system. You don't try and produce the bass from your satellite boxes. You have it coming from basically the bottom end.
That picture, were they the speakers?
This one?
Yeah.
Yeah. Well, you can see the little ones here. They're actually, dare I say, Quest speakers. Shameless self-promotion here, but that's the HPI 2.5 system. Now, I don't know where they put the sub, right? I'm sure that there's bucket loads of it somewhere, but you'll notice, like, you've got, and these 600 watt speakers, they're only little, but if you're sitting at that table, you've got one there, another set over the other side. A sub, the way that the bass performs, it's a real rolling signal that will carry through a room quite well. So you can be a lot further from the bass, but and that's where most of the power is. But these things, once again, you cross that at 100 hertz, you don't actually need a lot of power to get that really in people's faces. So,
Frank, in home theatre, the subs often, it's recommended that you put them up against walls, depending on placement in the corner or away from the corner.
well, there is a reason for that. The reason basically is the way a wave travels through a room. If wherever the sound is being generated has a wall behind it and a floor next to it, they call that a half space loading, or actually a quarter space loading when you put it in a corner like that. Now, if I talk to you like that, okay, it doesn't do anything for the quality of my sound, but it actually focuses the energy, you see. And now, in mid-range, you do that, sounds awful, but if you do it, but that effect doesn't happen on bass. So what you have is a natural horn-loaded amplification. So once you put it in a corner, and it's a trick they used to do back in the 50s and early 60s, they used to have what they called a corner horn, where you had a little speaker like this and this massive great tunnel of channels inside the box, and you'd put the box next to the wall and the wall would become part of the horn. And you'd have like a 10-inch speaker what would come out of those ports would be this most massive amount of bottom end, because when you measure the length of all the path lengths, there's about 12 feet or 3 or 4 metres of path length that acts like an organ pipe. So you'd have this massive output of bass from a relatively small speaker. Well, now they just use lots of power and a high excursion driver. But same thing, positioning of bass is very important. If you've just got it hanging in free space, you will have to use 4 times the power to get the same effect. And in fact, in a lot of rooms, as the bass signal's bouncing around the room, you imagine a brick. You throw a brick into a swimming pool and you get this nice big wave comes out. In a smaller pool, the big wave comes out, hits all the sides and bounces back. And it breaks up into a multiplicity of little wavelets. Now, as that wave's coming, emanating from your bass source, and another wave is coming back from the back wall, there are certain parts of the rooms where they will encounter each other, and depending on the frequency, it will either boost or you'll lose it. So you'll have, I don't know if you've ever been in a room, you walk around and somewhere the bass is just buffo, move over here and there's nothing. Now inevitably there's nothing where they want it and it's buffo behind the bar shaking, bottles off the shelves or something. Now that is just a nature of the way waves develop through rooms and how you position them. There's a whole bunch of physics connected to how you set up bass frequencies, which, bass systems, which we're not going to worry about here. But the point being, there's the old saying, put up 1 or 100. You put enough of them around the place, you'll be right. So this kind of installation is now becoming the trick, where you have it as distributed as possible, and if there's somewhere where it's too loud, you just turn it down. You just zone it, basically. You have as many zones. So you have lots of zones, and of course they can do it now with audio processors, where you can sit there and you can equalise each zone, and you get quite flash. But there's ways you can do this without actually going to this level of complexity. But here's another example. This one's in a church satellite system. There's subs built under the stage. There's another place. This is a bar in Brunswick Street. This is a little 8-inch high-powered top box. You can see there's a sub stashed under the seat. There's ways you can hide these. Now, as you walk around the place, it actually sounds like a nightclub. Here's an even smaller one. They're 5-inch speakers. The sub is actually, it's a picture of a sub in a cupboard. That's how, that points out the top of the cupboard into the roof. That one's a curtain house. Curtain house in Elizabeth Street. There's a whole lot of nightclubs in there. Anyway, there's a tequila bar in there. That's in that. You walk into that place, once again, you can see how this has been located. It's up in a corner. That generates a potentially ugly reflection, but it kind of works in there. Sounds like a much bigger, you walk in and the place sounds like a nightclub and you go, where's the sound system? Well, it's everywhere. That's where the sound system is, and the subs are stashed under chairs, under bits of furniture and in cupboards, and it's quite extraordinary. There's even a trick they've done where they get a couple of these and they've got them pointed at a wall. They're not even pointed where the crowd is, they've just pointed at a big blank wall, and you walk in and it's because the sound is reflecting straight off the wall. You look around and you go, it's a concrete wall, where's the sound system? You don't hear it coming from behind you, you actually hear it from the wall. There's lots of very clever little things you can do, because they wanted the sound coming from there, but they didn't want the sound system there, typical architect. Now, the other trick with low impedance systems is what we call the multi-way crossover. Now, in the case of a big one, each high, mids and lows, they're powered by separate amplifiers. You'd have a system controller or a crossover. The way a lot of the modern ones are done, you've got a mixing system. What we would have called a crossover in the old days, that's now a digital processor that has equalisation and compression and limiting, all sorts of stuff. Divides the frequency up into what the frequency that loudspeaker requires. In your hi-fi system there'll be a passive version of this. That's really how it's done. Now, here we have an old one and a modern one. There's nothing new about this. There's your old ugly piece of heap of rubbish. You know? That's probably in India or something. But that's how it was. And each one of these is a different band pass. This is a modern one where you have a sub here. That's a bass. They're bass cabinets. These boxes have both mid-range and HF in them. So that one's actually a 4 or 5-way system. Now, a word you might hear is line array if you're doing low impedance installs. People say, oh, you know, we want a line array. And you say, why? They say, because my customer wants one. You say, why does your customer want one? Because someone else has got one, right? The current fashion in doing a lot of these kind of installations is the line array. It is completely wrong. Line arrays were designed, essentially what they do is, a line array is the same as one giant speaker. Now, when you put a group of speakers next to each other, they tend to interfere with each other, and it degrades. It means you get a non-uniform signal, acoustic wave coming out. The way they focus energy and the way they're designed, they're trying to make like having one box in an environment where one box is not going to be loud enough. They're okay in this big environment. Once you start doing something like this, you'll notice how many of them you have to have, how much sight lines, you know, they interrupt. To make them work, they've got to be a certain length, and most people that install them don't understand that and never put in enough boxes. So they're actually a very poor solution, but at the moment it's a fashion statement. Here's a comparison. Here's that last picture. That whole vast expense of messing around can be replaced by a pair of boxes. Here's a venue of a similar size. The entire thing is being covered by, can't even see them here. There's there you go, 4 boxes to a side. Now that gives completely uniform coverage with just four boxes. And of course there's the subs under the stage. Now, the whole thing of running satellite boxes is that it's an energy distribution problem. In a lot of these kind of rooms that are very reflective, what you want is clear voice. No sound guy gets fired because the voice is too clear. So if you're ever doing any of this sort of stuff, talk to the guys here, because I can give you an example actually. This is another one with subs and satellites, but anyway, here's one. Now, this one was a church in Traralgon that was, they rang up, their problem was, this was, I think it's St Michael's in Traralgon. Now, we're talking an old Skippy congregation. They're all hard of hearing, and they have an Indian priest who had talks with the thickest Indian accent you've ever heard in your life. So consequently they were complaining that they couldn't hear the priest. The other thing they had was, I don't know if it's in this picture, maybe I've got a picture of it. No, not there. You know, they have a thing where they, you know, people come out and they have a communion, and of course the priest would walk out with his lapel mic tucked under his cassock and deliver communion and walk right in front of the PA. Consequently, it would feed back. So it was absolutely not happening. So they rang up the local Sparky, who I think was a member of the congregation, and his main job was television aerials. So of course they thought, oh well, he's an expert, he'll know something about sound. So consequently, the television aerial man rung radio parts to need a new sound system, you know. So anyway, they sold him this, and you get the right thing and the job's easy. He turned up, he put it all up, switched it on, worked like a ripper. Now if he had rung anybody else, they would have sold him a line array, or they would have sold him, you know, $100,000 worth of PA, and it just would have been, you can just imagine someone, you know, TV era guy trying to put in a complicated PA, it'd be a total mess. So doing this kind of installation, don't follow the fashion, just rings, you know, as I said, the guys here actually know all this stuff, as much as a lot of people come here to buy bits and pieces. That there's actually a terrific quantity of intellectual property here. Now, here's another one, same kind of system, that's Angela Merkel. Another thing you can do is what's called the delayed system. Now, up the back of the room, we have there's a second little pair of speakers. As the sound travels up a room, obviously, as I said, you know, you go twice the distance, you've lost 4 times the energy, unless the system is designed to focus the energy in a particular way that loss becomes less. You're going to have, by the time you've turned this up to be loud enough, that mic is going to be useless. So the other thing that you can do is what's called a delay, where now if you just put a couple of speakers there, there's going to be an echo. So anybody that's around the middle there is going to have this distracting echo, and it's going to destroy the intelligibility. So what they do, anyone ever used a delay? Ever heard of a delay system?
Tunnels they use the machine.
That's right. Now, what you do, sound travels at 1 foot per millisecond. So if you're 200 feet away, it's 200 milliseconds. Now, by the time you hit 200 milliseconds, that's an echo. Now, forgetting about the room reflections, which, by the way, by the time you're halfway up the room, you're hearing more twanging off the ceiling than you're hearing directly from the PA. And it's worse in a low ceiling. You're just getting reflections, and that, as I said earlier, washes over the consonant sounds, which even if it's loud enough, you're just going to lose every 3rd or 4th word, and it's actually quite stressful because was that cat or sat or, you know, and then you disengage, right, because you go, this is all rubbish, you know. So the idea of the delay is that as the wave is progressing up the room, what's coming out of your little satellite speakers, and they don't need to be big and it doesn't need to be a lot of power, what comes out of your satellite speakers is timed so that at, let's say, 30 feet away, at 30 milliseconds, that delay speaker is 30 milliseconds behind in time the front speaker. So it allows that wave to catch up before it starts. Now, what you can, in some places, if you've got them sighted perfectly, it will work perfectly. But your chance of sighting it perfectly is about 5% because of reasons of the room, for whatever reason. So there's a little trick you can do where you fool the ear. The ear can't resolve less than 20 milliseconds as a delay. So you extend the delays a little so that you make it, instead of being 30 milliseconds, 45 milliseconds, which gives you a much greater latitude of space. And what happens is, it's quite bizarre when you're standing there, because you can have a speaker right here, especially if you extend the delays a little bit, and you hear that one, the one over there. That's actually where the sound focus is. And it's quite maddening. This is often done in concerts and in certain rooms where you're gonna where it means you don't have to run the front system so hard, so your feedback threshold is going to be much lower, and it gives you a more uniform sound up the room. And people come up and you're sitting there at a mixing desk and they're going, hey mate, speakers are off, you know. But in actual fact they are on, and if you did turn them off, they wouldn't understand a single word anyone was saying. So that's the delayed system, which if you get a real tricky room, once again, your architect designed tunnel, and they don't understand that the word auditorium is Latin for place of hearing, you see, so they'll just design some horrid piece of crap with no sight lines and massive reflections everywhere and the rest of it. The delayed system is another trick you can use. Lecture theatres, it works in lecture theatres, and the great thing is you can do it with ceiling speakers as well. If you've got a situation where you have to have the dreaded invisible PA, you can run a ring of ceiling speakers, you can set it up as a delay, and Bob's your uncle, you can get it. You can use a reasonably cheap sound system and get terrific coverage. Getting back to this point with the multi-way speakers, we have your big amp rack set up. Well, There's a few products. Here's one where you can have the whole lot in a box. Way system in a box. You can run subs and satellites. You can set the thing up to give you the your uniform sound coverage. You basically can plug 4 top boxes, a pair of subs. The thing sounds like a nightclub in a little box. Relatively inexpensive package. There's a venue, Sanctuary Lakes. They've got something. Each one of their function rooms runs it. I'll move forward and wind this up because I think we're probably running out of time. Just in a bit of selfish self-promotion, we've got some new product we're bringing out soon. This is a waterproof system that's coming out shortly. High performance 100 volt line or 16 ohms, which means you can run a lot of them off a low impedance amp and retain higher audio quality if you want to. We've tested that down to a metre in water. It'll still work, a metre underwater. There's a bracket system for installing them. I can't bring the site up at the moment, but I'll leave it at that. A funky trick's been done where we managed to fit an 8-inch speaker into a 6.5-inch box by completely redesigning the way the loudspeaker's made. We also have a series, what we refer to as MS, that's the Sandringham Yacht Club. That's been sitting there now for 4 years. Looks as good as the day it was installed. So low cost, that's an IP rated, not as highly IP rated as the new one, but it's another one that we do. Any questions? I've probably flogged your ears long enough now if you've got something you'd like to ask me, or a dud gig, or something that you installed that didn't work, or that someone's, got the impossible job for you. Give us a try. I'm also available at, these guys know where I am. Any questions that you think of later, you want to email me or ring me. We're only in Tullamarine, so thank you for your time and attention.